Thunderstorms are one of the most common types of weather. We've probably all seen at least one thunderstorm in our lives. But do you know what the main driving force behind a thunderstorm is? Well, that would be convection. Convection is defined as the movement in a gas or liquid in which the warmer parts move up and the cooler parts move down. Let's use a household example for demonstration. Look closely at this pot of boiling water. Hot water rises to the surface as it boils. This is what causes the bubbles, and occasionally steam, to form. Atmospheric convection works similarly, except you'd need to replace the water from this example with air. The terms thunderstorm and convection are often interchanged in error. The truth is that thunderstorms are only one type of convection. Oceanic convection, sea breezes, and thunderstorms are three good examples of convective forces in action. The first type of convection we will cover is oceanic convection. Oceanic convection is a convective process of cooler and warmer waters that drive the world's ocean currents, known as the thermohaline circulation. The currents are driven by cold temperatures at the poles. The cold polar temperatures cool down the ocean near the poles, resulting in it becoming denser and sinking, in which new warmer water replaces it. Near the equator, as warmer water is being pushed towards the poles, it gets replaced by deeper water. This cycle, however, unlike atmospheric convection, is very slow, taking on the span of 1,000 years. Next, we will discuss the sea breeze system, which works in nearly the opposite way of oceanic currents, in that it's driven by warmth rather than cold, or increased versus decreased heat. The sea breeze cycle works as the sun rapidly heats coastal areas, hence causing a temperature gradient between the air right above the land and the air right above the sea. The warmer air at the coast then rises and expands, which generates a higher pressure aloft. Meanwhile, over the sea, since there is a lack of rising air, the pressure aloft is relatively lower, causing a pressure gradient. Since air flows from high to low pressure, air begins to flow towards the sea. The air also cools, then sinks in the process, and pushes air near the sea towards the coast. This can keep coastal areas very cool in the summer, while areas further inland can be 10 to 20 degrees warmer. Finally, we will discuss thunderstorms, which is the most common use of the term in meteorology. The reason thunderstorms are called convection is due to the formation and development of a thunderstorm. First, the sun heats a warm, moist air mass until it becomes buoyant. An air mass becomes buoyant when, as it rises, it remains warmer than the surrounding air. And since warmer air is less dense, there will be an upward force on it, like oil and water. As it rises, it starts to produce a cloud. At this stage, you will see many cumulus clouds, and most don't develop into much. However, the strongest updrafts eventually keep growing and growing, since its temperature continues to be warmer than the surroundings until it reaches the tropopause, in which it cannot rise further as surrounding temperatures are increasing, acting as an inversion on the updraft. Remember, convection is a cycle of a warmer fluid rising and a cooler fluid sinking, and as cloud droplets become larger and develop into rain droplets, the surrounding air becomes rain-cooled and thus becomes colder than surrounding air and begins to sink. Finally, this rain-cooled downdraft hits the surface, which usually hits as a gust of wind and heavy downpours, and cools the temperatures in the area. Finally, the rain-cooled downdraft can choke off the warm air updraft, which eventually weakens and dissipates the thunderstorm. We hope this video helped you learn more about the basic meaning and processes of convection. Please feel free to leave your questions down in the comments section. See you next time!